Okay, so this is question 4 of June 2011, paper 1, pure mathematics, variant 2. Please refer the question. So question 4 says a curve has an equation y is equal, I'll just write this down, y is equal to 4 by 3x minus 4, and P is 2, 2 is a point on the curve. So P is on the curve and it has the coordinates 2, 2. That is x coordinate 2 and y coordinate 2. Find the equation of the tangent to the curve at P. Now, if we do not recognize this, it's a question in differentiation. So I'll use another color. Use purple. So we have to differentiate this equation over here and arrive at our answer. So first, let's do the differentiation. As we did an integration, let's bring all the x variables from the bottom to the top. So this x variable we have here, we bring to the bottom to the top. How do we do that? So let's rewrite this as y is equal to 4 into 3x minus 4, the whole to the power of minus 1. How do we do that? We just took everything from the bottom, put it at the top, and negated the power. The power here was plus 1, so the power on the top will be negated, which will be minus 1. Now, we use something called a chain rule. The chain rule. Okay, so what is the chain rule? Chain rule is basically substitution. I'll give you a step-by-step analysis using this as our example. So let's take any variable t, correct, and equate it to whatever is inside here, not the power. We'll take the power. We won't take the power into consideration. We equate it into whatever is inside here. So we take t is equal to 3x minus 4, correct? So we can rewrite our equation as y is equal to 4 into t to the power of minus 1. Now, the symbol for differentiation of y with respect to x is dy by dx. But in this case, in this equation that we have here, we cannot do dy by dx because we have only a variable t. So we can say that dy by dx is equal to dy by dt into dt by dx, as these two can cancel out and give us dy by dx. But this is another way to rewrite it. This is basically another way to rewrite it and makes our life easier. It's called a chain rule. So let's say dy by dx is equal to dy by dt. So dy by dt in this case is equal to, we differentiate y, that is this, with respect to t, that is this. So let's differentiate. We have minus 4 t to the power of minus 2, correct? And then this is equal to, this is into, now how do we differentiate this? We used the power rule. We took the power from here, brought it and multiplied it with the coefficient over here, and reduced the power by 1. In integration, we added a power, but in differentiation, we subtract a power. Now, dt by dx, as we have over here, is equal to 3. Am I correct? Yep. So we have this equal to minus 4 into what is t equal to 3x minus 4. 3x minus 4 divided by 3x minus 4, the whole squared. I brought the power back down into 3. So minus 4 into 3. So this is equal to minus 12 divided by 3x minus 4, the whole squared. Now, please take this down. This is dy by dx. Correct? Now, we need to find the tangent at the point P 2, 2. I'm just writing it down here because I'm going to clear the screen. I hope you've taken this down. Correct? So, now how do we do this? Well, we have an x over here, correct? And this is our x coordinate 2. So to find the slope, that is the tangent of the slope of the tangent, we have to substitute our x coordinate over here, this x coordinate over here, into the x coordinate over here. This will give us dy by dx. dy by dx, as you know, is our tangent when we apply it to graphs. So our m at 2, 2, m we decipher as slope, is equal to minus 12 divided by 3 into 2, we are substituting 2, minus 4, the whole squared, which is equal to minus 12, divided by 6 minus 4, 2 squared 4, which is equal to minus 3. Am I correct? So we have minus 3. Now what did the equation ask? So what is the question ask? Find the equation of the tangent. Now, as you can see, there's not only differentiation applied over here, but there's also an earlier concept that you learned in 8th and 9th, that is equation of a line. I'm going to be clearing this page, so I hope you've taken that down. Now, we have 1 point, 2, 2, and we have a slope minus 3. Correct? So, we can use the point slope form, as I call it. That is y minus y2. We can do this as y2, and we can do this as x2. Or we can do this as x1. It doesn't matter. And we can do this as y1. It's fine. So we'll take this as y1. Y minus y1 is equal to m, which we found in earlier, into x minus x1. y1, x1 is basically the coordinates that we have. Since the line is going through this point, we can take this as our in our equation. So how do we do this? Y minus y1 is equal to 2, and m is equal to minus 3 into x minus x1 is equal to 2. We just substituted. So y minus 2 is equal to minus 3x plus 6. Y is equal to minus 3x plus 6 plus 2 is plus 8. So this should be our final equation. Let's check if that's correct. 4 part 1. And y minus, they haven't simplified it in this case, but y minus 2 is equal to minus 3 into x minus 2, which is what we have got over here. And that'll be automatically equal to what we have got over here. Now, a good tip to solve these answer these problems, keep the equation of the line always in standard form. That is ax plus by equal to c, or ax plus by plus c equal to 0. It doesn't matter which form you keep it in, but these both are standard form. So if you keep it in this form, the examiner will like you immediately. So now let's go on to part 2. I will clear this page. I hope you people have taken it down. Let's go on to part 2 of the question. That is, in this case, one second. Find the angle that this tangent makes with the x-axis. So what I would do is draw a diagram. Correct? We have our y-axis here. We have our x-axis here. We have a tangent at minus 3 going through 2, 2. So 2, 2. Correct? 2, 2, which is here, and it's going at the minus 3 slope, which is like this. I'm not drawing it accurately, but it's like this. This coordinate is 8. Sorry. This y coordinate is 8, x coordinate is 0. So this is 0, 8. And we need to find this angle. So what have you learned in your trigonometry? You know that this length, this y length, that's this length over here. I'm going to draw this in a different color. Orange. You know that this length over here is 8. As you can find over here, you can always find where the line intercepts the y-axis. That's called the y-intercept. And you know where this intercepts the x-axis. We'll find that right now. It's called the X-Intercept. To find the X-Intercept, take the equation of the line that we have over here and make y 0, find x. So in this case, 0 is equal to minus 3x plus 8. So we have 3x is equal to 8, x is equal to 8 by 3. So this part is 8 by 3. Correct? Now we don't need this calculation anymore. I'll just erase this. I hope you people have taken it down. We have x-intercept 8 by 3. So this length over here is 8 by 3. Now, this angle is basically, according to trigonometry, this is the opposite. This is the opposite. This is the adjacent. Opposite over adjacent, I'm using short forms over here, is equal to tan of the angle x. We'll take this as the angle x. So x is equal to tan inverse. When you move the trigonometry function to the other side, you have to do the inverse of it. So opposite in this case is 8 by 3. Correct? Which is equal to, let me get my calculator out over here. 8 by 3 is 3. Tan inverse of answer is equal to 71 degrees. 71.5 degrees. Always put it to 3 significant digits. They like that. So 71.6 degrees in this case. Now that should be our correct answer. Let's check the marking scheme. Or 71.6 degrees. That is correct. So this is the problem. If you have any questions, please email me. Otherwise, good luck.